Hello all, I'm Bhavya. In this video, I'm going to present you my internship project titled Microcontroller Based Washing Machine Simulation using PicsimLab. So this project allowed me to gain hands-on experience in embedded systems. So let's dive in. So this internship started with the module Advanced C Programming module. So here I revisited the C fundamentals like keywords, data types, loops, and functions, and also revised control structures like if-else, switch, and loops. And also we covered about pointers and memories and all. And also there is some new concept that I came to know in this course is that Endianess. Uh, I don't know about what the concept of Endianess before, but from this internship, this is the new thing that I learned. So, so talking about what is Endianess, it simply is a byte order in memory. So it refers to how data is stored in memory. So there are two types in Endianness, little endians and big endians. Little endian means LSB stored at lowest address. So the companies like Intel, AMD and all other most of the companies use little endian over big endian. So big endian means the MSB is stored at the lowest address. The Motorola company uses this big endian, but many of the companies choose little endian over big endian. So where LSB is stored at the lowest address. So this is what an endian means. So moving on, next coming to, we talked about introduction to embedded systems. So embedded systems are simply a dedicated systems with specific functions. We can simply say that they are integration of hardware and software to do a specific task. We can simply say that also. So these embedded systems can operate under real-time constraints. They are small, reliable, and resource constrained. So there are the examples of embedded systems are washing machine. The project itself, the washing machine we are doing simulation of a washing machine. So that is an embedded system. And microwave ovens and heart monitors are also examples of embedded systems. So moving on, we have three categories in embedded systems. One is standalone embedded systems where these works without external systems. The best example for this is Tesla self-driving cars. So they do not have any external systems. It completely depends on their own intelligence. So these Tesla self-driving cars are the best examples of standalone embedded systems. So this is one example. And moving on, the next category of embedded system is networked embedded systems communicates with other systems over a network. So the better example is smart home devices. Obviously, all devices in a smart home are connected, right? Other systems are connected over a network. So these are networked embedded systems. And the another category is real-time embedded systems. So they respond within a strict timing constraints. The real-time example is an airbag system in vehicles, obviously. When a particular timing arises, these airbags are programmed in such a way to work. So these are the three categories in embedded systems. Moving on, we have components and memory in embedded systems. So an embedded systems have several key components like microcontroller, memory, input-output units, and embedded software, etc. So these are few components of a microcontroller. So obviously there is also here memory is the most important in embedded systems. So there we know the basic types of memory, RAM, ROM, and there is also a memory called flash. So this is actually rewritable one. So these are about the components and memory in embedded systems. So moving on, we talked about microcontrollers and data sheets. To say simply, microcontroller is a mini computer with CPU, RAM, and input-output ports. So that is about a microcontroller. Next is data sheets. So these data sheets are technical documents provided by the manufacturer of a microcontroller. So every microcontroller that you take have a separate data sheet related to it. So this data sheet describes microcontroller architecture, pin configuration, memory map, timers, etc. So this particular data sheets are very essential for writing accurate and efficient programs. So basically you can say that the data sheet is your map when programming a microcontroller. So you definitely need to go through or study the data sheet of a particular microcontroller if you want to program it in a way to do some task. So these data sheets are very essential for us to understand them so that we can then only we can write an accurate code. So that is about microcontrollers and data sheets. So now moving on, coming to the project objective, the goal is to simulate a real-world washing machine system using PicsimLab. So we need to replicate the washing machine components, cycles, and operations here. So we need to include features like power on off and washing machine program selection, water level selection, wash, rinse and spin cycles, door status and completion of it. So this is the objective. We need to mimic the real world washing machine system using PicsimLab. So that is the main objective here. Moving on, coming to the tools used here, one is PicsimLab. So it is a microcontroller simulator for real-time virtual hardware behavior. So it is a tool we need to install on our laptops to simulate the microcontroller in real time. And the next tool is MPLAB IDE. So it is integrated development environment for PIC microcontroller coding. And the next thing is XC8 Compiler. So it compiles C programming targeting 8-bit pin MCUs. So it is XC8 Compiler is to compile the C programs that you write in your MPLAB IDE. So next thing is CLCD simulation, simulated display using to show the washing stages and messages. So now another last one is PIC microcontroller. Here in this project we used a PIC microcontroller, that is PIC 16F877A. So this is the microcontroller that we have used in this particular simulation. So for implementing washing machine logic, we need this microcontroller. We worked on this microcontroller in our project. So moving on, the peripherals used are switches. We used switches for different purposes. We used switch 1, switch 4, switch 5 and switch 6 for different purposes. Switch 1 is to simulate the door status, and switch 4 we used to navigate through options, and switch 5 we used to power on or start the program, and switch 6 we used to pause or stop the program that is running. So these are the switches we have used. And the next thing is CLCD. It shows shows where the washing machine status is. It is an LCD display actually. So it shows the stages. Now next thing is buzzer. We have used the buzzer, so alert for door open or programming. So the buzzer is used when the door is open. It allows the buzzer. It gives the buzzer to alert the user, and when the program is end, then also buzzer is used. And the next thing is we use the motor to simulate washing process. Whenever the washing process is currently going, the motor is going to rotate. So in order to simulate the washing process, we used a motor, or we can say that is a simply fan. We used a fan to simulate the washing process. So these are few peripherals we have used in this project. And now coming to this is the entire flow of our project. So initially we start, and then we power on the washing machine, and then we select the washing program, and then we select water level, and then we need to choose start or stop. And after clicking on stop, the cycles like washing, spin and rinse are going to be executed. And after while executing it is going to check whether the door is open or closed. So it checks the door, and then after completing it shows the completion message, and that's it. That is the end. So this is the entire flow of a project. So this is the simulation of this one. So first let me load the hex file which I have stored in the washing machine project. So this is the washing machine project file. So let me open it. Let me load the hex. So now initially the LED is showing the press key 5 to power on washing machine. So this is the first ever screen that we get by implementing this project. So it is saying that we need to click key 5 to power on the washing machine. So let me just check whether it will on for other switches. So this is switch 1, switch 2, switch 3, switch 4 and switch 5. So if I press switch 1 or switch 2 or switch 3 or switch 4, washing machine should not power on. So only when I press this switch 5, it should power on. So let me press switch 5. As you can see, the washing machine is powering on. It is showing the display like this. So now, yeah, we got this display of washing program. So these are few options that we need to select here. So in order to navigate these particular options, we need to use switch 4 to navigate through options. Like if I click short press this switch 4, I can move on to the next options: delicates, whites, stain wash, and eco cottons, woolens, bed sheets, rinse plus dry. So these are many options that we have given in the washing machine program. So after dry only, there is an option for wash only, and last one is aqua store. So in order to select any of these options, we need to long press this particular switch 4 to select it. So let me select delegates now. So I need to long press this switch 4 to get selected. So yes, after long pressing that particular option is selected, now I need to choose the water level. So we have a few levels. Again, we are using switch 4 to navigate. So one is auto, another option is low, another we have medium, high water level, and maximum water level. Here also the same thing. Switch 4 is used to select one particular option. You need to long press this particular switch 4 to select it. So I'm pressing max, or I'm selecting it by long pressing it. Now as you can see, the LCD display is changed to press switch 5 and switch 6 stop. So I need to either click on switch 5 or to switch 6. So if I click switch 5, this process is going to get started. So I click on switch 5. As you can see, delegates now function is started. So wash function is going on, and that particular thing is representing by rotating this fan. As you can see, the timer is also started, and all these things. It is going to be started. As you can see, after wash, it went to the rinse option. So after rinse, it is going to be third cycle, that is spin. So this fan represents that. As you can see, the buzzer is also came now. So the buzzer indicates that program is ended or complete. So again, it returned to the first ever screen. So this is one thing where we do not pause or anything we did. So it just made it. So now let me again select this delegates. Long pressing the switch 4 to do that. Again, we got the water level. So let me choose auto now. So I'm choosing long pressing the switch 4 to do this. So after water level, like you see, I need to do start or stop. So initially, before that, in the previous execution, I clicked on switch 5 to start this particular program. So if I click stop, like this is switch 6 actually. So if I press this program should stop and again come back to the normal. So as you can see, I press the switch 6 and now it came back. So now again, I want to change the option now. So I go to villains maybe. Let's move to villains. Yeah. Now let me select this by long pressing switch 4. I long pressed it. Now this is water level. So again we need to choose one thing. So I'm choosing low. Again long pressing the switch 4 to get selected. Yes, now let me go to switch 5. So the progress is going to be started. We have 26 seconds it seems. So now it is actually washing. So here as you can see, if I click switch 5, it gets start, and if I click switch 6, the process will be paused. So let me click switch 6 now. This is switch 6. Let me click it. So as you can see, the fan is stopped and everything, timer is also get stopped because I paused the particular one by clicking 6. So I pause it now. If I again click switch 5, every process gets started again. As you can see the fan is again started moving on, started rotating, and the timer is also started. And that same, the buzzer is get blown after completing and it's saying remove clothes. Now there is also another possibility that door. If the door is open, this particular process not gonna happen. So let me just show you. Here in order to mimic the door, we are using switch 1 to mimic the door. So first let me just choose some other bed sheets now. Long pressing the switch 4 to select that. Now water level. So I'm going to choose high. So yeah, long pressing the switch 4 to select that. And now, so let me start the process by clicking switch 5. Now as you can see, it takes 58 minutes to do his bed sheets. Now as you can see, the timer started and the washing process is happening. That is referred by this buzzer. fan. Now I'm going to click this switch one. So let's see what happens. As you can see, it is displaying door is open. So please close the door. So if I remove my hand on the switch one, the process gets again started. If you click on this, the door is open and the fan and all the everything is closed, right? And now when I release this on my switch one, so again the process gets continued and everything is gonna happen. So these are the few things that we have mimicked all the way. So as you can see, it is now wash is completed, rinse is going on. So whenever I click switch 1, it shows that the door is open. So we need to close the door. Then only the process will be continued. The buzzer is also be kept. So this is the process that's actually happening now. 12:11. So after ring, the last stage is spin. So yeah, as you can see, spin is also there. So after timer is completed and the process is completed, fan is gonna get off. As you can see, fan is off and also buzzer is also blown to say that this process is completed. So this is the entire flow of the project. So this is how you have. So let me just go from first. Let me show you again how the process again. Let me reload last. Simply, first I'm going to press switch 5 to power on this washing machine. As you can see, powering on screen is showing. So after this, I should choose any of the program from the washing program. So in order to navigate, I'm using switch 4 now. So I'm clicking switch 4. It is scrolling down, as you can see. So I'm long pressing this to select it. Again, same. I'm going to use switch 4 to navigate and long pressing switch 4 to get select the particular option. And now I'm clicking switch 5 to get start the process, as it is showing program and time. So it is taking so much time now. As you can see, washing time. And it is a particularly long time because we chosen based on the type and type of washing program we have chosen and the water level we have chosen. Based on that, the timer varies accordingly. So we take the timer information based on a data, so that it will vary accordingly. So and we have three cycles: wash, rinse, and spin, right? So these three are taken the time accordingly. So this is what's happening. So now if I can also pause this by clicking switch 6. So if I click switch 6, the process is paused, and again to start it, I need to again click on switch 5. So these are the few processes that we can have. And another thing that we seen is that when I click switch 1, the door is open. And it is showing the message, the door is open, please close the door. And when I remove my hand on it, it is again working normally, right? So it is still timer is started and buzzer is, but when we click switch 5, it is paused, so everything stops. And when I click switch 5, everything starts. And similarly, when I click on switch 1, everything is stopped now. The display screen is completely changed and the buzzer is started buzzing and the fan is also stopped. So these are the few things that happen. So for these things, we have written the program. As you can see, the program completed, remove groups. So now, yeah. So this is the entire flow of the project. So this is everything. So in this project, I learned about how to program a microcontroller to display these particular levels, and through the internship, I understood how to debug. Debugging is really needed here. So in the period of internship, I can say that I became better in debugging. Like, I can understand the errors that it is giving whenever program is not working. I'm able to debug better now. And so through this project I got an understanding about how to program a microcontroller and simulate a real-time washing machine now. So this is the project of microcontroller based washing machine simulation using PicsimLab. So thank you for listening till the end.